Welcome to LABrary. I am Miss Kathleen if you haven't joined us before, and today we're going to explore some new concepts. In LABrary, we talk about the world around us and how it works with us interacting in it. Later, I'll share a challenge or two for you to take, and hopefully you'll share your experiences with us by either emailing me at kathleen@mld.org or through social media at Meridian Library. Today, we are going to explore capillary action. Let's spell capillary. C-A-P-I-L-L-A-R-Y. So you ask, what is a capillary? Well, plants have capillaries and animals, including humans, have capillaries as well. And they serve similar functions in plants and animals in that they help to move nutrients through our systems to get us either the water or the nutrients that our body needs or that the plant needs. I like to look at the etymology of a word. Etymology just means the origin or where a word comes from and what parts come from where. So I looked up the word capillary, and it comes from the Latin capillus or capillaris, meaning hair. In Italian, the word for hair is capelli. One hair is a capello. So does the word origin tell us something about the size of capillaries? I think that it does. It tells us that they're very, very thin. Take a look at your own hair. Here is a picture of one human hair magnified 200 times. Okay, so capillaries are thin. What function do they serve? Well, in plants, capillaries bring water up from the roots into the parts of the plant that need it. In humans, capillaries bring up oxygen, nutrients, and waste are exchanged between the blood and the tissues. Humans have vast networks of capillaries in our bodies. In fact, this might be hard to imagine, but we humans have around 10 billion capillaries in our bodies. They're the smallest of the blood vessels that we have in our bodies. Think about it this way. Capillaries in the human body are only 1 cell thick. So blood moves very slowly through capillaries. As the blood cells move through a capillary, nutrients, oxygen, and food leave the blood and then enter the body's cells. And then gases like oxygen and carbon dioxide and nutrients and wastes pass in both directions, so coming and going, along or across the capillary walls. I know that's a lot of information, so let's summarize. Capillaries help the body to get the nutrients it needs and to get rid of waste it doesn't need. Okay, so what about capillaries in plants? Okay, so when we're talking about capillary action in plants, there are a couple of words that will help us to understand what's happening and how the water goes into the capillaries in a plant. So the first word is called cohesion. That's when alike molecules stick to each other. In this case, it's the water. So the water molecules are sticking to each other. And then the other word is called adhesion. And that just means that the capillaries in the plant roots adhere to the water, or the water adheres to the plant capillaries. And when they cling to and are forced upward by the surface tension of the capillary, that equals the capillary action. So that's how the water is getting forced up into the tree or the plant. In the case of our diagram, we used a tree, but that's what's happening. So when, we've all put a straw into water, I put a little bit of coloring in the water so that you could see it easily. So when we put a straw into water, there is something happening with the water molecules inside the straw. The water molecules are adhering to the inside of the straw. So the level of the water inside the straw is slightly higher than it is in the water glass. And I'm sorry I don't have a clear straw, so you can't see, but I put my finger over the top so you can at least see that there's quite a bit of water in there. This is something that you could do at home. Challenge number 1. Okay, if you have a clear drinking straw, then you can try that at home. Another thing that I would like us to try, and this is the big challenge for this week. So our big challenge for this week is to make a walking water experiment. We're going to be using water and food coloring, and several glasses and paper towels. So we know how absorbent paper towels are, right? And their structure is made so that they'll absorb as much water as possible.
Okay, so here are 5 glasses that are all the same type of glasses. I don't have any water in my glasses yet, but what you'll do is fill your glasses full of the same amount of water, except for this one here in the middle. This one will have no water in it. And then you will put your paper towels in after they have water and food coloring in them, okay? So paper towels go in last. The only reason that I put them in there is because I wanted to show you kind of how they snake in and out. All I did was take a piece of paper towel like this for each one of those, folded in half and then in quarters, and then folded it in half lengthwise. Then 1/2 goes in one glass and 1/2 goes into the next one, and so on and so on. So these 4, the 4 on the outside, are going to have the same amount of water before you put the paper towel in. And before you put the paper towels in, make sure that you put the same number of drops of different food coloring into those 4 cups or glasses. This one is going to have nothing in it. And I want you to predict what will happen with this one. Do you think that anything will happen with it? Or do you think that's where the crawling of the water will stop? So if you do the experiment, which I hope you do, if you take the challenge, please share it with us on social media at Meridian Library, or email me at Kathleen@mld.org.
Thank you so much for joining us today for LABrary. Mr. Travis is up next with the second part of his program from last week, where he will talk about the challenge that you guys had last week. And hopefully I will see some comments or some shared experiments from those of you who have taken up the challenge for this week. And I will see you next week here on LABrary. Thanks again for joining us. Bye-bye.
All right. Welcome back to the LABrary. So this week we're going to come back around to talk about the challenge that I set out for us last week. So last week we talked about seeds. We talked about how seeds are planted, how in the right conditions they go from a state of sort of germination and they will grow. And we also talked a little bit about the fact that sometimes seeds, while sometimes we will plant them ourselves, sometimes, but with most plants, the seeds have got to move around so they can start plants in other places. So there are different ways they can do that. Like we looked at like a dandelion, when you can blow on the seeds of a dandelion and the seeds will go everywhere. There's seeds in fruit, that when the fruit falls down from like a tree or a bush and the fruit decomposes, that the seeds will come out and then they will get into the ground. Sometimes animals will move them around, squirrels and birds and that kind of stuff. But sometimes plants themselves have like a way to sort of distribute the seeds on their own. And so like when the seeds fall, they will spin or they will kind of float down, because you don't want all the seeds right at the bottom of your plant or your tree. You want them to move around. So our challenge this week was to make something using some paper, paper clips, tape, and some scissors to see what we could do to make a design to get our seeds as far away from where we drop it as possible, so our plants can grow. So this is what I put together here. One second. So I started here with some paper, some scissors, paper clips, and some tape. And I looked all over. I thought I had some sunflower seeds, but I didn't. So I used some dried beans, but they're basically going to go right around the same size and shape. So those, I had some beans that were going to be my seeds. So I made a few different designs for using the paper clips to carry or to hold my beans. So I kind of undid the paper clips and wrapped them around, or just kind of made a big L shape and taped the seeds to a paper clip. So then the other ends of the paper clip are going to be where I put paper. So I've got one design here where one of the hints that I gave you guys is to look at what a helicopter and how a helicopter flies. And when a helicopter that has two blades, when it spins, the blades aren't level. They're angled a little bit to help and when they spin, it pushes the air down, and that's how a helicopter goes up. And so I tried some angling my paper on this design, and then I made another design kind of like that, but I got two different pieces of paper and then kind of had them angled at two different directions. So I taped the paper onto the paper clips. And finally I did one like similar to that, but I did I made the wings, the propeller wings, a lot longer on this one. So like this one, it was kind of shorter. And then I did one that was quite a bit longer. I just made a few different designs. And then I wanted to see what would happen if I went away from the sort of the helicopter look, and what happens if we made like a hang glider. So I got a big piece of paper and then taped a couple of paper clips together and put our seed right in the middle with some tape, and just seeing like if I dropped that, would it go any further, that kind of stuff. Didn't really do anything else to the paper. So those were my designs as far as going for trying some designs out to see what would happen. So I have a video here of how it went. One we'll look at definitely worked better than the others. And then, none of them were perfect. I'll say that. If I were doing this at home or doing this at a program, I would, basically you test them all. You test them all once, you test them all a couple of times, and then based on, what worked and what didn't work, I would go back and revisit my design. So if I were to do this again, I would definitely, there was the one with the longer wings seemed to move better. And so I would probably look at that design to get a bit more. The other thing I noticed is that for as high as I could drop it, because I only kind of just stood on my tiptoes, some of these things started to really spin at the end, but it took a while to get going, and it pretty much fell straight. So I'd be interested to see what happened if I dropped it from a higher height, like if it was a really tall tree, how far away some of these would go. But it was hard for me to really get that action just from my tests. So, but that was something I thought about. I did see some spinning as it went, so that encouraged me. But so I think often with these things, nothing is perfect. You prototype, you try it once, you learn, and then you can keep on building and building again. So, I have ideas for to do this again, like what I would try next. So I hope you tried it, or if you haven't tried it yet, I hope this will give you an idea of something you can try at home over the summer. And we'll look at the video here to see how I did. Travis here, Mr. Travis with Edgar Dragon Poe, the Meridian Meridian LABrary bearded dragon. We're going to test some of my prototypes for my seed delivery system. So what we're going to do is drop it from a tree, that tree over there, and see how far they go. Again, here's Edgar right here, and here's our tree. I'm just going to have it fall from about as high as we can. We'll see what happens. Ready? 1, 2, 3. Oh boy, that just fell straight down. Just straight down. No spin at all. Let's see, we'll do this. I'm going to try and throw it up in the air and see what happens. Oh, it did. Actually, that started to spin after a little bit. Let's see. Ah. Okay, let's see if we can... not great. Alright, we're going to try it with this one. Okay, Edgar's looking. Here's this one. We'll see what happens. Oh, that definitely spun. That definitely spun. It's hard to capture it on the video, and but it falls pretty fast. It definitely falls fast. So let's try this one with the bigger propeller. I know this isn't the greatest video in the world because it's... Okay, so I'm going to try this one and see what happens. Here we go. Oh, that one actually did fly pretty well. It didn't spin, but... Oh, that one did pretty well, huh, Edgar? I wonder if we tilted it a little bit more here, if we could force it to spin. Try one more. Try one more. Okay, ready? Ooh, that one did well. So far, by far, the best one is this helicopter kind of thing with the big wings. It really does slow it down. Oh, yeah, that's pretty good. I don't know. Okay, finally, we're gonna try the hang glider. See what that does. All right, Edgar? All right, here we go. Hang glider. 2, 3, 2, 1. Oh, not much. Oh. I'd have to figure out maybe how to angle it to get it to project. But I definitely got... So, at least of all of the ones that I did, this one, the sort of the helicopter shape, and with the bigger wings, that's definitely the best. But I was going to see, let me get the chair here. We can actually look how this tree delivers its seeds. You can see right up here, we actually have some seeds. So I'm going to pull these out. Probably should have looked at this before I started making my own. So look at this one. This has, you can see right here, it's got the seeds sort of right in the middle. And then it's got 2 big wings. And then when it drops, let's see what happens. Oh, that's kind of cool. I don't know if you could see that, but when these drop, they definitely spin. So that's another way that you could deliver the seeds. So anyway, that's so far definitely my best of all of them was the big wings, and then slightly angled, but I still didn't really get a great spin. So if I was going to spend more time on it, I would work to see what I could do to get a spin happening. But again, this definitely, as it fell away. And, you know, it was from a higher, and also if I know if it was from higher up, it would spin as well. So, but anyway, that's it.